Hello again. Today we are going to go over some problems from chapter 26. This is the chapter on DC circuits. So let's take a look at what the problems you're going to be asked to do for today are. So we're going to start with the recitation problems. And so the first problem is number 10. And so these problems are on page 700, and even 700, these problems start. Three 1.70 kilo ohm resistors can be connected in 4 different ways, making combinations of series and or parallel circuits. So you have to figure out what those 4 combinations are and what is the net resistance in each case. So 2 of them should be obvious enough. You'll need to do a little bit of thinking about the 3rd and the 4th, and then figure out the net total equivalent resistance in each case. That brings us to number 15. A close inspection of an electric circuit reveals that a 480 ohm resistor was inadvertently soldered in the place where a 370 ohm resistor is needed. How can this be fixed without removing anything from the existing circuit? So if you keep the 480 ohm resistor in place, but you want a total resistance of 370 ohms, what do you need to connect with the 480 ohm resistor and how? So it's basically 2 parts. Then we get to problem 28, and this is a Kirchhoff's rules problem. You're asked to determine the terminal voltage of each battery in figure 2646. So if you look at the problem, there are 2 power sources. There are 2 batteries. They each have an internal resistance, and you want to figure out what the terminal voltage is. So the terminal voltage is, of a given battery is the output voltage minus the current times the internal resistance of the battery. So you have the output voltage, and then your you have to factor in the resistance of the battery itself. And in a lot of circuits, the internal resistance can be neglected because it's tiny compared to the total overall resistance, but not in every case. And so here you have a small external resistance of 6.6 ohms, and so which is not big enough to render the internal resistance as negligible. So the first thing you're going to need to do is figure out the total current, which direction it's going, because that actually affects the problem. And so for one of the batteries, I will be negative, that it's going into the positive end and out the negative end. And so you can need to figure out the current in which direction it's going. And so the terminal voltage in that case will actually be larger than the output voltage of the battery. And in some cases that'll happen, but this is one where you should think about it carefully. Then we get to number 30. A network of 5 equal resistors is connected to the battery as shown in figure 2648. And so it's fairly complicated looking, but if you go through the steps with Kirchhoff's laws, it's actually going to simplify fairly easily. The best way to go about this problem is you're going to set up a bunch of different equations and basically solve each equation for one unknown and sort of work your way back. And you'll reach a point where there's one equation where you'll get a value for the current through one of the resistors, and once you have that, everything else falls into place. But it's a little bit involved. Again, please, if you have any questions, do not hesitate to ask for help. And also, if you're in any way not sure of your answers, whether it's that problem or any of the others, please ask for help. That brings us to problem 45. 2 3.8 microfarad capacitors, 2 2.2 kilo ohm resistors, and a 12.0 volt source are connected in series. Starting from the uncharged state, how long does it take for the current to drop from its initial value to 1.50 1.50 milliamps? So first, figure out the equivalent capacitance, then figure out the equivalent resistance, and then it becomes, your basic RC circuit problem. And so what's the initial value of the current? And again, you can figure that out from the equivalent resistance since you're given the total voltage. And then figure out how long it takes to drop from the initial value to 1.50 milliamps. And that brings us to number 46, the last of the recitation problems. How long does it take for the energy stored in a capacitor in a series RC circuit to reach 75% of its maximum value? So express it as a multiple of tau, the time constant. So you have Q as a function of time. The energy stored in a capacitor is Q squared over 2C. So you can figure out from that what the maximum energy stored is, and figure out what U is a function of time, and then figure out how long it takes to reach 75% of its maximum value. And it's basically similar to what we went over in class. There's going to be one more step because there's a squared term involved. And because U is equal to Q squared over 2C, there's going to be one more step in the problem, but it's not going to be that much more difficult than some problems you've already gone over. And that brings us to the 4 homework problems. The first, determine the equivalent resistance of the circuit shown in figure 2639. And so look at that example. And then figure out the voltage across each resistor. So if you're having trouble visualizing it, you can redraw the circuit in a way that you think it makes it easier to figure out what's going on. And what's in series and what's in parallel, and then how do you figure out the resistance of the circuit. And then figure out the voltage across each resistor. Now remember, where you have a parallel segment, the voltage is the same across each branch. Where you have 2 segments connected in series with each other, the equivalent resistances of each add together, or the equivalent voltages, or the voltages across each segment add together as well. So keep those in mind. And then the next example is problem 32. Calculate the currents in each resistor of figure 2650. So this is a Kirchhoff's rules problem. There are 2 loops and 2 junctions. So you'll have 3 equations with 3 unknowns, basically. And so we went over problems like this in class. If you have any questions about them, don't hesitate to email me and ask for help. 34, determine the magnitudes and directions of the currents in each resistor shown in 2652. This is another Kirchhoff's law problem. And you're given the voltages and you're given the resistances. And so ignore the internal resistances of the batteries in part A. In part B, assume each battery has an internal resistance of 1.0 ohms. So you're adding a little detail to the problem. But otherwise, you know all the resistances and you know the voltage sources, and you're being asked to solve for the currents. And that brings us to 48, the RC circuit of figure 2659. So you're given the resistance, you're given the capacitance. The capacitor has an initial voltage at t equals 0 when the switch is closed. How long does it take to the capacitor discharge to 0.10% of its initial voltage? So the voltage across the capacitor is equal to Q over C, and we are discharging in this circuit. So so the voltage, there's a lab experiment that's just like this as far as charging and discharging a capacitor. The voltage across the discharging capacitor is basically the same thing as the current. The same equation has the charge across the discharging capacitor. The only difference is you're dividing the charge by C to get the voltage. So those are your 10 problems. And again, if you have any questions, do not hesitate to email me. If you have any doubts about the solution to your problem, do not hesitate to email me and ask for help. Okay, thanks a lot. I'll see you again soon.